Is it going? It's going. Okay? So this chapter is all about, we learned all these are called the fundamental identities. This page is in your book. It's also posted on my Schoology. There's a document in chapter 5 on Schoology on today's lesson where you could look at this. I wouldn't want you to write this all down now. But you should know these things. And you can use these things to prove, to do trigonometric proofs, which is some of what we're going to be doing in this chapter. It's not the whole chapter, but that's part of it. And then we learn how to use these to solve and derive the formulas for double angle, half angle, sum of angle formulas. And then we solve some trig equations, which is I kind of like. So that's kind of what this chapter is all about. So this first section, 5.1, is you're using fundamental identities to simplify trigonometric expressions. Okay, but in the first, so one thing that they say, or a first example, I'm just going to go through some examples and then let you kind of work. Cosine, so if you have something that says cosine of u, they don't always use theta. Cosine of u equals, I messed up already, I meant to write cosecant of u. So cosecant of u, so if I say that cosecant, right? No, I still wrote it down wrong. One more try. Secant of u, okay? Last try. Secant of u is equal to negative 3/5. Negative 3/5. And tan of u is greater than 0. What's wrong?
That's negative 3/2, not negative 3/5.
Oh, I meant negative 3/2. Okay. I wrote down what I meant. I just said the wrong thing. Okay. My brain's on Friday mode, I guess. Okay. Tan of u is hey, no crumpling things in class. It's greater than 0. Okay. You should be writing things down. Pencil, class, math, pencil. My God. Okay. And tan of u is greater than 0. It helps you stick it in your brain when you write things down. Some people say, oh, I just like to watch. But then A, you can't refer back to your notes, and B, it doesn't stick in your brain. There's a physiological connection to writing stuff down and sticking it into your brain. It's actually studies show. Really, I kid you not. And they'll say, find all 6 trig functions. Okay? So, functions. So in this case, what we've done before is draw a triangle and then use the triangle to figure this out. You can still do it that way, but they want you to use these identities to do this in this case, rather than actually do it. So the first and probably the easiest one to find, just by using those identities, would be what? Cosine, right? So cosine u would just be the reciprocal of secant u, so that'd be negative 2/3, okay? But then you could use one of these trig identities, like this one over here, to find sine of u, could you not? Okay? So I'm going to use this one, because I could take any of these 3 and rewrite, I could rewrite cosine u squared. Cosine u squared is equal to what? Cosine squared u, is equal to 1 minus sine squared u. Sine squared u, okay? So I could plug in cosine in here and solve this for sine, or I could solve it for sine and plug it. Either way, so I'm going to go negative 2/3, square it, okay, equals 1 minus sine squared. So now I'm trying to find sine, okay, sine squared u. And then when I square negative 2/3, what do I get? Don't say something good. 4/9. 4/9 equals 1 minus sine squared u. I guess I should have left sine squared by itself, but in any case, then I could subtract 1 from both sides. That's 4/9 minus 1. How many ninths? Negative 5/9. Could you still see that? Negative 5/9 equals negative sine squared. So you could get rid of the negatives and say that sine squared u equals 5/9. So sine of u, I'm just going to go up here. Sine of u, oh, I can move over. Sine of u equals square root of 5/9, plus or minus, okay? Sine of u is equal to 5, square root of 5, I'll be right with you, over 3. What were you going to say, Hannah?
Well, you can't, so you just, how is it you just got rid of the negative?
How did I just get rid of the negative? Because in my original problem, remember, I was told that, what was I told? Where'd that tangent go? Oh, it's above. I was told that tangent u is greater than 0, right? So you have to think, so you kind of have to think which quadrant I'm in, right? Tangent is positive and secant and cosine are negative down here. So this is actually, and that means that sine would be actually negative. Right? Because this means when tangent is positive and secant and cosine are negative, I'm in the fourth quadrant.
So it wouldn't be?
It would be negative. This one would be negative, right?
So you wouldn't write I with 5/3?
You wouldn't write what?
Like the imaginary number symbol root 5/3?
No imaginary numbers, because that's if the negative is inside the square root. The negative is outside the square root. Okay? And then cosecant, I could use a identity by flipping it upside down. 3 over square root of 5, negative. If I like, I can rationalize that and write it as negative 3 root of 5 over 5. Questions? Am I going too fast? What's wrong?
I just want to know, like, what did you say next to the square root of 5?
Next to the square root here?
Yes.
That's a negative sign. Because I know that secant is negative and tangent is positive, the only place that occurs is down here. Did I say the fourth quadrant? It's down here in the third quadrant, right? Because cosine's negative here, but since cosine and sine are negative, that's going to make tangent positive, right? And so sine would have to be negative as well. Okay? And then to find tangent and cotangent, how do I do that using these identities? What over what? What's tangent? Tangent is sine over cosine. So then I have to take negative root of 5 over 3 and divide it by negative 2 over 3, which is the same as multiplying by negative 3 over 2. And the negatives go away and the 3's go away. And I get tangent u is equal to, root of 5 over 2. Root of 5 over 2. And then cotangent would be the reciprocal of that. Cotangent of u would be 2 over root of 5, which rationalizes to 2 root of 5 over 5. Now, probably in most cases, I wouldn't want to do that. I would just draw a triangle in the third quadrant and do all the, like what we've been doing, okay? But just to show you it can be done with just the identities. But you still have to know something about the unit circle that you're in the third quadrant over there. Right? Got that? You want me to pause? Pause. Okay, while you write that down, I just want to make sure I get through most of this stuff. Whoops, my class is in the wrong place. Okay. Next thing that you're going to see, new piece of paper, is they're just having you simplify expressions to try to get used to try to get the steps that you're going to have to use when you're doing more complicated identities, okay? So cosine squared x minus sine x, and they would say something like simplify. 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 Anyone see something I can do in there? Trent, do you see something I could do in there? What could I do, Hannah?
You divide sine of x from.
Yeah, well, you can't really divide it because there's nothing on the other side, right? You can't just divide something away, but you can factor it out, okay? So if I were to see something like this, you just kind of have to do lots of practice problems and say, oh, I think I could factor out a sine of x from both of those. Anyone know why I would want to do something like that, Ella?
Because cosine squared of x minus 1 is sine squared of x.
Almost, okay? So cosine squared x minus 1 is very close to 1 minus cosine squared x, which would be sine squared of x, right? But it's not exactly the same. So how could I turn this into that?
Multiply by negative 1.
Yeah, so if I were to multiply this by negative 1, so this is kind of a trick that you have to use once in a while. Multiply this through by negative 1, that makes this positive and that negative. So this is equal to cosine squared x minus 1, right? Okay. So what I can do is rewrite this as sine of x times negative 1 times 1 minus cosine squared x. Why the heck would I want to do that? How would I know how to do that? I think you just have to do lots of practice and know that that's what you have to do, okay? What's 1 minus cosine squared x equal to? Sine squared x. And the reason I want to do that is because now I can take this negative 1, pull it out in front. I can take that sine of x, put it there. I can take that here and put it there. And how many sines of x do I have altogether? To the third power. So this can be simplified to negative sine cubed of x. Got it? How would I know how to do that? I don't know. But in most cases, it will say show that this is equal to this. Okay? So you would have a place you're trying to go with it. Okay? Yes?
Why would you factor out the negative 1?
Why would I factor out the negative 1? So that I could, because 1 minus cosine squared x I know is sine squared x. Okay? But cosine squared x, I had cosine squared x minus 1 in here, and that's not equal to sine squared x. That's equal to, yeah, I throw in a negative 1 in there, and then it is, you see?
Yeah.
Okay?
I'm just curious why. Oh, because sine of
It's
x.
just flipped.
It just flips it over.
If you rewrote the question and put it like
I'm
subtracting
asking why
cosine.
the separate sine of x. Why didn't you just write negative sine of x?
Oh, I could have, yes. I could have just written that.
Because you have to multiply everything by negative
Yeah. That's good. Okay? All right. So that's one type of thing you'll see. What else might you see? Then you might see something like this that says secant. They'll say simplify. Secant. Or they might say factor, not simplify. They might say factor secant squared theta minus 1. So secant squared theta minus 1, I believe, is equal to, what's that equal to? Tangent squared theta? Tangent squared theta from that trig identity. But in this case, they want you to factor, because eventually what you're going to be doing is solving equations. And it's just like factoring x squared minus 1. What does x squared minus 1 factor to?
x plus 1.
Yeah, this is equal to x plus 1. So a lot of times when it says factor, just pretend that those secant squareds and stuff like that are x's, okay? So factor secant squared theta minus 1, that's just equal to secant theta plus 1 times secant theta minus 1. Okay? And that's all. And eventually what we're going to be doing is you're going to have this equal to 0, and you're going to have to solve those two equations just like you'd solve the quadratic equation. It is a quadratic equation, but it's got secants and stuff in it. Okay? So that's all that means. All right? Would you know how to factor this? Factor 4 tan squared theta plus tan theta minus 3. You should be good at factoring, sir, since you're in advanced class. Yes, sir. Yeah, just pretend that this is like 4x squared plus x minus 3. Okay? So if it helps you to think about that, and you're good at factoring things in algebra, okay, you can just do that. This has to be a 2 or a 2 or a 4 or 1, right? You know, what has to go here? What two numbers have to go here and here? What has to go there and there? Has to multiply to 3. So you have to have a 3 somewhere and a 1 somewhere. Okay? Then you got to figure out a way where they multiply to 4. Let's see. They add to 1 and multiply to 4. Is it 2 and 2?
Yeah.
2x. Is that right? No.
What's 1 and 4?
It's 1 and 4, isn't it? 4. Yeah, it's 1 and 4. Right. So this becomes a factoring problem. If you don't know how to factor, you should practice. So I would put this would be 4x. This would be 4x. Yeah. 4x. And this would be a 1x, right? Those multiply, and then you have to figure out where to put your signs. Since this is positive, you put a positive here, and you put a negative there. That works, right? When you FOIL it out, you get that, okay? So you get 4. So then when I rewrite this, you don't want to write that. That's not the right answer. The right answer is 4 tan theta plus 3 times 4 tan theta minus 1. Okay? And then if we were solving equations, which we'll be doing later on in the chapter, you would set it equal to 0 and you'd solve each piece of those individually. Yes, Trent?
It shouldn't be 4 tan.
Oh, wait.
It would just be tan theta.
Thank you, I missed it. Okay? That should just be 10. Okay? That should just be 10. Okay? Okay? You should get this new app for your phone. I heard on the news yesterday. Okay, thank you, Mr. Leader. Come again. That's because I listened to you guys. Because you told me the wrong answer. It's not my fault, okay? I did. So this should be a minus, this should be a plus, right? Minus, plus, there we go. That works. That's a minus. Let's fix it. That's a minus, and that's a plus, okay? Minus, plus. Next time I'll be better. Okay? Promise. All right. What if I saw something that looked, here's where it gets kind of fun, okay? What if I saw something that looked like this? And they say factor. Cosecant squared x minus cotangent of x minus cotangent of x minus 3. And they say factor. Any ideas? Yes. See, the reason I was getting those factor problems wrong is because I made them up. And when you make up factor problems, it's called factor fiction. I made that one up. Okay. Okay. So anyway, if you see something that looks like this, what you want to do, we have an identity that says that cosecant squared. Let's go back. Where was that identity? See this one right here? Boom, boom, boom. This one right here. Cosecant squared is equal to 1 plus cotangent squared. Okay? So I'm going to reuse this identity to rewrite this with a cotangent in it, because I can't factor things that have cosecants and cotangents, kind of like factoring things that have x and y's. Okay? So I'm going to rewrite this as cotangent squared x plus 1 minus cotangent x minus 3. And then I combine my like terms. Did I mess up again?
No.
Cotangent squared x minus cotangent x minus 2. And let's see if I can factor this one correctly. I'm trying to go fast because I need to get to some other stuff. Cotangent x, negative 2 goes here, right? And plus 1 goes there. Did I do that right? I think I did. Okay? And that's how that factors. I'm going to pause. Pause. Go look on there. Okay? Next one. Sometimes I'll say, and these are all of these are getting you ready to learn how to do, to prove trig identities and solve trig equations. And so they're all kind of some different techniques for doing different things. Cotangent of t, let's call it x instead of t, because that'll be cotangent of sine of x, cotangent of x, cosine of x. Okay? And they say simplify. We've already done stuff kind of like this, but I just want to show you one thing. Okay? If I saw something like this, probably my first inclination would be to write everything in terms of sines and cosines. So you could write cosine x as cotangent of x as cosine over sine times cosine of x. Why would I do that? Why would I want to do that? The sines don't cancel yet, okay? So what I can do now at this point is to multiply this by sine of x over sine of x. I'm finding a common denominator. Okay, this is kind of a trick, because then on the top I'm going to get sine squared of x plus cosine squared x. That whole thing over what? Sine of x, because that's my common denominator. That's why I multiplied this by sine of x over sine of x. What's sine squared x plus cosine squared x equal to? 1. So this whole top is equal to 1. So now I could write this as 1 over sine of x. What's 1 over sine of x equal to? Cosecant of x. See the way that works? Isn't that kind of fun? They're kind of fun. They're like little puzzles, you know? Trying to make it like, don't you think it's kind of fun? Who thinks it's kind of fun?
No, no.
You don't think? What?
So when you multiply through, you only multiply it through in once, so you're more or less saying all that times sine over sine, and then you cancel once. You didn't have to multiply everything through by sine over sine.
No, because I want to find, it's kind of like if you have 1 plus 2 over 3, right? I want to put those things together, right? So I multiply this by 3 over 3 so I can find a common denominator, right? That's all I'm doing. I'm finding a common denominator. So I'm multiplying this by 3 over 3, right?
Yep.
So I get 3 plus 2, the whole thing over 3, which is 5 over 3. That's all I'm doing here is I'm writing the whole thing over a common denominator. Get it? Okay. Okay, another technique that comes up a lot, okay, is to, you want to get, new page. Another thing you'll see quite a bit is rewrite so there's no fractions, okay? So they'll say 1 plus, this 1 plus sine x, and they'll say get rid of the fractions. Get rid, they don't say it, okay? Get rid of fractions. Anyone have any idea what I could do with that? What?
Multiply the thing by 1 plus sine of x.
Not 1 plus sine of x. You multiply by what's called the conjugate, okay? Kind of what you did back when you're getting rid of rationalizing denominators. You multiply by the conjugate like that, okay? And when I do that, on the bottom, I FOIL this, right? And what happens is the two middle terms, sine of x and negative sine of x, disappear. And so on the bottom, I have just 1 minus sine squared x. And on the top, I have 1 minus sine of x. What's 1 minus sine squared of x equal to? Cosine squared of x, okay? So I have 1 minus sine of x. And now what I can do is break this into 2 fractions, okay? One fraction being 1 over cosine squared of x, and one fraction being minus sine of x over cos squared of x. And I want to write this without any fractions. How could this be written without a fraction? This is secant squared x, and this is equal to, no, you could write it, yeah, tangent times something else. Yep, this can be written as tangent x times secant x. Do you guys see where that comes from? Secant x, because sine over cosine is tangent and 1 over cosine is secant. So now I rewrote it without any fractions. Why would I want to do that? I don't know, just an exercise in doing, hey, you know what? If you don't pay attention and you don't write down anything, I'm sorry it's not the most exciting thing, you're probably not going to do very well on the test.
I start taking notes most often recently.
Well, you should write it down, then you could look at your notes again, and then you could try to learn from your notes. Okay? I don't have too much sympathy for people sitting here with their heads on their desks. I'm sorry it's not the most exciting thing, but it's the material that we have to learn in this class. Okay? It's the curriculum. And that's why you take notes, so you can look at them and try to review them and understand. Okay? Okay, last thing you're going to see is something like this. This is called trig substitution. Trig substitution. And this is something that they do in calculus, okay? And they're just kind of setting you up for calculus type problem. So they'll give you something like this. Theta is less than pi over 2, and theta is greater than 0. And they say substitute x equals 2 tan theta into square root of 4 plus x squared to write square root of 4 plus x squared as a function of theta. and I'll talk a little bit about why you would want to do this, okay? Function of theta, okay? So what they want to do here is take, did I write that down right? Whoops, I meant to put a 2 in front of here, sorry. 2, should be a 2 right there, equals 2 tan theta, okay? So what you do is you take this and you sub it into here, okay? And when you do that, you have square root of 4 plus 2 tan theta quantity squared, like this, okay? That is equal to the square root of 4. When I square this, what do I have? What's 2 squared? 4 tangent squared theta. Does anyone see anything I can do with those 4s? Factor out of 4. So now what I have, this is equal to the square root of 4 times 1 plus tangent squared theta. Okay? That's equal to the square root of 4. What's 1 plus tangent squared theta equal to? Secant squared theta. 4 times secant squared theta. And the reason I did that is because now I can take the square root of this. What's the square root of 4? What's the square root of secant squared? Secant theta. Okay? Why would I ever want to do something like that? Because in calculus, you have things like this that are very difficult to take integrals of. So you'll see a problem that looks like this, and I'll say, find the integral of this, meaning find the area under the curve like that. And this is almost impossible to integrate using conventional integration techniques. So what they do is something called trig substitution, where they take a trig function and they sub it in for something else. And this is very easy to integrate, okay? 2 secant theta, and then, so you change it, and then you do the integral up. That's why you learn it here, because it's a calculus thing that they're setting you up to do, okay? So that's about it, okay? So I'm done. I'm going to stop. I'm going to say...